It's nice to see you again. We are now looking at the top. We've turned over to page 13 of the probability packet so that we can really get into this probability of multiple events idea, or compound events, a combination of two or more simple events occurring as the outcome that you're trying to find the probability of. And here with the addition rule, we're going to speak of whether two events are going to be mutually exclusive or not, whether or not they can happen at the same time. So if we're thinking about, like, five gives some concrete examples. You're rolling a standard die, six-sided, outcomes are 1 through 6. Are the given events mutually exclusive, meaning can they happen at the same time or not? I would say rolling a 2 and rolling a 3 on a die, two separate events, could not happen simultaneously. These events are mutually exclusive. I'll say yes for this one. I can't think of an example where you could get a 2 and a 3 in the same roll. Rolling an even number and a multiple of 3. Could that happen simultaneously? Well, I think it could. I feel like this one is not mutually exclusive. And let's give the non-example. Even number that is a multiple of 3, 6. I'll say 6 is both. It's both even and it's a multiple of 3. So you've got this overlap. Rolling an even number and a prime number. Got to think of our evens and primes. So even outcomes, 2, 4, 6. Prime outcomes. I know 3, 5, and no 7, 3 and 5 since we're rolling a die. But how about 2? 2 is also a prime number. Here's your overlap. 2 is the non-example. These are not mutually exclusive. And is the fourth example mutually exclusive? Rolling an even number and a number less than 2. So 2, 4, 6 for the evens. Less than 2 is a 1. Could not happen at the same time. I'm going to say yes for the final example. These two events described are disjoint from one another. They're mutually exclusive. Disjoint makes me think of a Venn diagram, and you've got these two cases of the addition rule for probability. When events couldn't happen at the same time, there is zero overlap, or is going to mean that you add. That's why they call this the addition rule. When you see the word or, I'll put this here, or is always going to means add. You add the two probabilities together. We've been doing this. We did it on the warm-up before, right? We said rolling a 2 or rolling a 6 probability, we had added their probabilities on a die. For events something to watch out for events that have overlap, so events described that could happen simultaneously, or still means add. You're still going to add the first probability to the second probability of each of those events. You're going to subtract the overlap. Subtract the probability of the case that you double counted, that falls in case A and case B simultaneously. And I want to try examples with stuff that we've already been looking at, starting with cards. I want to think of a deck of cards and get used to some of these questions. So it says I've got a standard deck, and I'm going to take my cards, I'm going to shuffle them good, and I'm going to pick a random card from the deck, and what's the odds that this is a queen or a jack? Well, or means add. I'm going to add up the probability of, and I'll write this as two separate fractions, but you don't have to. I'm just going to do it for emphasis. There are 4 queens in the deck out of 52, plus the 4 jacks in the deck out of 52. So or is going to signal that we add. Now maybe you just put an 8 over 52 to start with, or maybe you already reduced. Maybe you already made this 1 in 13 plus 1 in 13. That works as well. Final answer would reduce to 2 over 13. How about probability of a heart? Oh, let's see if I did get a queen or a jack. I didn't. I got a 3. All right, let's say I did that again. Shuffled up, picked a different card. What's the probability I pick a heart or a club? I want to separate these. I want to add up all the hearts out of the 52 cards. So that's a quarter of the deck, 13 hearts out of 52, and then plus the 13 clubs out of 52. Another thing I haven't really mentioned, so let's finish this one. You have 26 over 52, which logically should be a half. We should have been able to guess it. And you notice in examples A and B, even though I neglected to mention it, we didn't subtract off any overlap. So far we've been talking about mutually exclusive events. A card couldn't be both a queen and a jack at the same time, and a card couldn't be a heart and a club at the same time either. So you're just adding probabilities for those two without subtracting any overlap. How about probability of a red or a 10? I wonder if these events are mutually exclusive. So either way, I start the problem with the probability of getting a red card. So the 26 red cards out of 52, plus how many 10s? The 4 10s, one of each suit. I was saying the number 10. I meant to put 4 over 52. I feel like we are not in the mutually exclusive realm anymore. A card could both be red and 10, so we double counted. The two red 10s, the 10 of diamonds and the 10 of hearts, we put into this category for reds, and we double counted it in this category for 10s. So we are subtracting off the overlap. The two red 10s that got counted in both cases. So final answer, 26 4 30 minus 2, 28 over 52, reduced to 7/13, like that. You don't have to write this out separate, right? If you knew, okay, I've got all the red cards here accounted for, and I want to add maybe just the two black 10s instead of adding 4 and subtracting 2, that's fine. But here's where the subtracting the overlap comes into play. I'll put overlap there. And now we'll look at a heart or a 3. Now you tell me, are these events disjoint? Are they mutually exclusive? Or could they happen at the same time? And they could, right? Think of the overlap. So there are 26 hearts. There are still 4 3s, but there's one of them that got counted twice. The 3 of hearts needs to get subtracted off because we don't want to count it in both categories. So you've got 30 and then oh, what's it? Did you guys catch my mistake? Let's look back. Are there 26 hearts? No, Miss Wesley. There are 13 of each suit. So how about that? 13 looks a little better. Plus 4, 17 minus 1, 16 out of 52. And we can reduce, make it 4/13. Last one. Face card or spade, right? We talked about face cards in the previous lesson. You've got all the cards with faces on them. So the Jack, Queen, King of all 4 suits. There are 12 face cards total out of 52. Plus all the spades. I see or means plus, so all the spades. This time I'll put the right answer, 13 over 52 for number of cards in a suit. Minus the overlap is going to be the spade face cards. So how many are there? Well, of each suit, there's a jack, a queen, and a king. So subtract the 3 that were overlapping. So that's just 12 plus 10, 22 over 52. And we can call that 11 out of 26. So we've got cards in the mix. For 2 dice, I want you to pause the video and construct this little table here. I did it already to save us time. We want sums on the 2 dice, and this table just comes in handy so often. So you're adding the numbers there. Once you have the table down, this should be pretty quick, right? Think of your total outcomes, your 36 outcomes. That's a good denominator. It says, what's the probability you get a 2 or a 6, or means add, on the first die? Well, the first die, we don't really need the table for, right? Because you're just thinking of rolling 1 die instead of 2. So it's kind of starting easily for us. On the first die, there's actually only 6 possible outcomes. And getting a 2 would be, 2 or a 6 would be 2 of those outcomes out of 6. You have a 1 in 3 chance that just 1 die lands with a 2 or a 6. Now let's look to the table for these where it says sums. A sum of 7 or sum of 3. We want to add up all the 6 outcomes that give you a 7 plus all of the 1, 2 outcomes that give you a 3. I'm going to add this all in one fraction over the total number of outcomes, the 36. So there are the 6 7s and the 2 3s. We'll make it 8 out of 36 and reduce that to 4, we'll say 4. 8 out of 36. I guess if I cut them in half, right, 4 over 18, but how about 2 9ths? Does that look better? 2 9ths. Sum is greater than 8 or sum of 10. Well, greater than 8 are these 9s, 10s, 11s, 12s. So that's 4, 5, 6, 7, 8, 9, 10. So 10 out of 36. Or a sum of 10? Well, we kind of already counted those. This is a weird one. You could add the 3 outcomes that give you 10s. But you're going to have to subtract them anyway because they already got counted. These events are not mutually exclusive. The sums of 10s are already greater than 8. This is your solution. 10 over 36 reduced to, we'll cut those in half, 5/18. All right, a little weird. Okay, doubles or a sum of 6. Doubles, that's this diagonal here, right? 1 and 1, 2 and 2, 3 and 3. There's 6 outcomes that are doubles out of 36. Plus the sum of 6, which 1, 2, 3, 4, 5. But did you notice I double counted, right? This 6 right here was counted in both the doubles list and the 6s list. So we'll subtract off the overlap and have just 10 out of 36, which is the same answer as the last one, 5/18. 4 or 3 on either die. We got to think hard about this one. This one probably deserves a little star. 4 on a die would be these 6, not over counting, not double counting, plus 5 more, because I don't want to double count that 8. So 6, 7, 8, 9, 10, 11. There's 11 ways to get a 4 on a die. Plus, how many ways to get a 3? Is it also 11? These 6 ways, or these 6 ways in the 3 column, plus 5 more without double counting. So 11 ways to get a 36. Now, are these mutually exclusive, or is there a little bit of overlap? I actually double counted the outcomes that had to do with a 4 and a 3. There's 2 of those outcomes. I actually double counted getting a 4, 3, this 7 here, and getting a 3, 4, that 7 there. So we'll subtract off for the overlap. See if you agree with an answer like 20 over 36. And we can reduce that to 5 over 9. Divide both by 4. We're going to skip down to the bottom of the page where it says you choose a random 2-digit number from 10 to 99 inclusive. I have a question for you first at the bottom here. How many numbers are there from 10 to 99? If I take 99 minus 10, I get 89. There's actually 90 numbers. You got to think about it. You're including the 2 boundaries. So think about the 2 digits, right? For a 2-digit number, you have how many choices for the first digit? Well, it says from 10 to 99, so just 9 choices. The numbers 1 through 9. How many choices do you have for the second digit? 0 is now included. You have 10 choices for the second digit, 90 total outcomes, 92-digit numbers. Keep that in mind for your denominator. Let's get through a couple of these. It says probability the number has a 2 or a 4 in the tens place. Let's add up all the 20s. So there's 10 values out of that 90 that are 2 something. 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. And that's it. That's 10 of them, right? There should also be 10 that are in the 40s. 40 through 49 is 10 more of them. And we haven't included any overlap here. It's 20 over 90, and you get 2 9s. Probability the number has a 2 or a 4 in the ones place. How about? Well, how many have a number? I'll turn to red here. A number and then a 2. So that's how, and then I need a number and then a 4. Or means add. So we'll say for this one, a number and then 2. Well, 0 doesn't count as the first digit, so that would just be 12, 22, 32, 42, 52, 62, 72, 82, 92. That's 9 values out of 90 that are a digit and then the number 2. Try that. Same thing for 4. Number and 4 should be 9 out of 90, and you're going to get 18 90ths. And we can divide those both by 18 and get 1/5. Okay. Probability the number just has a 4 in it. Okay, so for has a 4 in it, we got to think. I would add up the 4 in the tens place and the 4 in the ones place. So what I mean by that is digit 4 in a digit, all the 40s, digit and 4, all the ones that end in 4, and we can subtract off any overlap if that's going to happen. So numbers in the 40s we've already done. There's 10 values out of 90 in the 40s. Numbers with the 4 in the ones place is going to be the 9 numbers, right? 14, 24, 34, all the way up to 94. So 9 out of 90. Now we got to think about overlap. Did we double count at all? And there should be one option that we double counted. There's one number that has a 4 in both places, and that's the number 44. I want to subtract off one case out of those 90 cases for the overlap. So this is one way to organize your thinking. You had 18 out of 90 again, and we get a repeat answer of 1/5. Part D is a little tricky, but it is a good follow-up to Part C. We can kind of use what we did in Part C to help us with this one. It says the number has a 4 or a 2 in it. Well, we just found out the odds that the number has a 4 in it. And I'm going to keep the denominator at 90. So 18 out of 90 is the probability the number would have a 4 in it. Or a 2 in it. Shouldn't that be, I'm just doing a shortcut here, shouldn't that be the same thing? Shouldn't that be all the 20s, all the ones that start with 2, and then plus all the ones with 2 and the 1s? We just have to subtract off the overlap, and the ones that are in both cases, all the 4s, all the 2s, right? I believe there are 2 values that are overlapped. 24 has a 4 and a 2, and 42 has a 4 and a 2. So minus the 2 over 90. Add across the top. We just did that in a little bit quicker of a way. So 34 over 90, and then reduced. I think you just get 17 over 45. We're actually going to end things there for now, but happy solving. Have a great day, and I will see you soon.